Alrighty, nerds, let's get after it. Last section of the chapter 3, section 3.8, solving nonlinear systems. So what is a system? We've already done solving systems of linear equations. That was, I think, chapter 1, maybe chapter 2. I can't remember, but it was two, where we were trying to figure out where two straight lines crossed each other, and we did that using substitution, elimination, and my least favorite, like solving by graphing. As usual, solving by graphing is only useful if your answers are pretty, right? I mean, solving by graphing doesn't really get you decimal answers or fraction answers. It only gets you integer whole number answers. I talked about that when we were graphing quadratics. Solving a quadratic by graphing, again, only really useful if you're going to get pretty answers. Well, solving a system just means you're trying to figure out where two objects cross each other if you were to have graphed them. But we don't want to have to graph them. Nonlinear means at least one of the objects is not a straight line. And if you can recall, go all the way back to section 3, is it 3.4? Maybe it was 3.4. Remember that homework that everybody was really confused on how to do the back, where I was like, hey, you could write different equations and see where the different ones cross each other. Remember doing that? That was homework number 5. So instead of what we did on the front, which was bring everything to one side and then figure out where a quadratic crosses the x-axis, I said, actually, you can manipulate this and have it as a quadratic and a non-quadratic and see where they cross each other. Well, that's because I was getting you ready for the last lesson of the chapter, which is where we don't want to have to solve by graphing, but you could. Here we have a quadratic. I recognize it as a quadratic because something is squared. Now, you actually don't know how to graph this. This has y squared, not x squared. This is a sideways parabola. That's not part of our curriculum anymore, so I don't teach it. But it is still a quadratic because one of my exponents is squared. This one has no exponents, so it's a straight line. So we're actually asking ourselves where a straight line crosses a sideways parabola. And if you read the title, you can see that we're going to solve this one using substitution. What we're going to do is we're going to either get x alone and plug in for x right here, or we're going to get y alone and plug in for y in two places. Please think smarter, not harder. You know you're trying to do as little work as possible. If you got y alone, first of all, you would have fractions because you'd have to divide by 2, and there's no number here to divide by 2. And second of all, if you solve for y, whatever you get y is, you're going to have to FOIL it there, then distribute, and you're going to have to distribute there. Can it be done? Of course. Do you want to do it? No. What you want to do is look to the variable that doesn't have exponents and plug in there, because that's going to make your life easier. So I want to know what x equals so I can stick it right there. Luckily, that second equation, x gets alone very, very easily. Bless you. The second equation shows us that x is 2y plus 7. And if you know what x equals, plug that in. Take what x equals and plug it into this equation. Right there. That is going to give us 2y plus 7 equals 2y squared plus 3y plus 1. Since it's a quadratic, get everything to one side, combine your like terms, and then hope that you could solve by factoring. If factoring doesn't work, you know you're going to have to use the quadratic formula or completing the square. You cannot solve a quadratic unless it equals 0. Alrighty, we have a quadratic that has a number in front of its leading term. That's not a 1. That means if it factors, it'll factor by the Lizzie method. Let's see, 2 times negative 6 is negative 12. Is there a way to multiply to get negative 12 and add to get 1? Wow, a phone call this early in the day? Anyway, so we were saying 2 times negative 6 is negative 12. Are there two numbers that multiply to negative 12 and add to 1? Yes, there are. So we can solve this by factoring using the Lizzie method. The two numbers that multiply to 2 times negative 6, which is negative 12. Actually, let's go ahead and write it off to the side. Trying to figure out which two numbers multiply to a times c, which is negative 12, 2 times negative 6. And they're going to add to that b term. That b term is 1. Yep. That's going to be negative 3 and positive 4. Those two numbers will multiply to negative 12 and will add to 1. The Lizzie method says you take those two numbers and you put them in your, oops, it's not an X, it's a Y. You take those two numbers and you put them in your parentheses, but you have to make sure that you put them over the A value. Because I kind of cheated a little bit when I multiplied this 2 to this negative 6. That changes the equation. You're not allowed to change it. So you have to make sure that you undo that multiplication right here. We reduce. Of course, the fraction 3 over 2 does not reduce. This fraction does. This is going to give us two values for y. And then once we know what our two values for y are, we can come back here, plug them in, and we will get our two values for x. It shows us that y equals positive 3 over 2 and y equals negative 2. Whoa, what? Because we're solving for y, right. That's only if you need to finish factoring. So if you need to finish factoring, and if I just said, hey, factor this quadratic, then yes, this would be 2y minus 3. But since we're trying to solve, what you would have ended up doing is this. You would have set it equal to 0. You would have added 3 to both sides. Then you would have divided by 2. And you would have gotten the same answer. So the reason why I like to solve by the Lizzie method is because it avoids me going through this process in green. It gets me to my answers a little bit faster. Come over here. Use these two purple values for y to solve for x. Let's see, I'll try to squeeze this in here. X equals 2 times plus 7. This is where we're going to drop in our 3 over 2. Luckily, this times 2 and this divide by 2 cancel each other out. And what you get is 3 plus 7. This is a solution then. A coordinate. Remember, all your coordinates are going to be x comma y. So one of your solutions is 10 comma 3/2. Remember, x always comes first. Then we got to get the other x value from the other y value. That is negative 4 plus 7, which is 3. So the other solution then is 3 comma negative 2. And since I've got math all over the place, I'll go ahead and circle them. Those are where your straight line and your sideways quadratic would cross each other. Got some questions in the field?
So you just set them equal and then you solve for one of the variables?
I didn't set them equal. I solved for one of the variables so I could substitute into the other equation. Then I had an equation with only one variable, brought it all to one side, and solved. Once I knew what that variable equaled, I used it to find the other variable.
And when you got x equals 10, it was because you plugged in y. Okay, yeah. That makes
Yeah, see, so I plugged in y right there. It gave me x equals 10. So that's the solution. And then I went from there. Yes?
Since we're about to go to the next one, I kind of point something out about the next one I just realized.
Well, let's look at it first. Are there any more questions about this first one before I scroll? It's not really scrolling before I slide the paper. No? Alrighty, Will, what do you notice?
You could get rid of the y squared by squaring the entire bottom equation, but here's the thing. You will end up with nothing.
No. If you square this bottom one, you can't just square each piece. It doesn't work that way. You'd have to square the whole side, which means on this side, you would have to FOIL, and you would end up with a term that has an x squared in it. and you would end up with a term that has an xy in it. So it would make your life much more difficult. You're not allowed to square each piece. Doesn't work like that. You have to square the whole side. It's a good idea, though. Yeah, foiling is going to make it a lot more work. Could we solve by substitution? Absolutely we could. Again, working smarter, not harder. I don't want to solve for y and plug in for y because there's a good chance I'm going to have to FOIL. So smarter, not harder would be to get x alone and then plug in to here. Or get this x alone and plug into here. But that's if you wanted to substitute. Could we substitute? We could. But I want you to see another method. Elimination. We've done elimination. Well, you did it in Algebra 1, and we did it this year with 2 straight lines. The way that we did that was we made the numbers in front of one of our letters match, and then we canceled straight down, either by adding the equations or subtracting the equations. You can't make these two y's match, because that's y squared and that's not. But we can easily make these x's match. Easily. The number that both 4 and 2 can easily become is 4, actually. So we don't have to do anything to the top equation. What we do need to do to the bottom equation is get a 4 on the front. So distribute either a 2 or a negative 2. That's completely up to you. If you want to always be able to add your 2 equations, then you need to be multiplying by something that will give them opposite symbols. I don't really care about all that. I just try to get the same number in front of both. And then I decide once they have the same number, do I need to, yes? That's what I was just saying. I'm going to do positive 2 because I don't care if they have opposite symbols. If you're a fan of always making them have opposite symbols so you can just add each time, then yeah, you need to multiply by negative 2. But I don't really care about all that. But if you do, and you are successful that way, then go for it. Okay? Distributing the 2 is going to get me 4x plus 2y equals negative 4. Because I have 4x and 4x, I need to subtract. But if you distributed a negative 2, obviously you would have negative 4x, negative 2y, positive 4. You'd be adding straight down. 4x minus 4x is 0 x's, so I don't need to write it anymore. Y squared minus 2y. Well, those aren't like terms. So all I can do is write y squared minus 2y. And 4 minus negative 4, that's 4 plus 4, or 8. Here I have another quadratic. Get it all to one side and solve. That means I'm going to need to subtract 8 from both sides. And just like last time, we have a quadratic in terms of y. So will you always have a quadratic in terms of y? No. It's just how it happened. Sometimes you'll have quadratics in terms of x. Are there 2 numbers that multiply to negative 8 that add to negative 2? Yes. Thank goodness. We can solve by factoring because I don't want to have to do the quadratic formula. Those 2 numbers are negative 4 and positive 2. What we could see then is that y takes on the values positive 4 and negative 2. Just like the last question, you could take these values for y, substitute them up here, and solve for x. Work smarter, not harder, please. Don't plug them in where you're going to have to square. That's just one more step. Plug them in where you're not going to have to. You'll get the same results, but I want you to be able to do less work. So I'm going to substitute my my y values into this bottom equation. I have space all over the place. Let's go here. 2x plus a y value equals negative 2. 2x plus a y value equals negative 2. This is where I'm dropping in those y values.
I have a question.
Yes, Will. Okay. What? Why do I have to pause the recording? Maybe is it a question about this?
Yeah.
Well, I don't want to pause it then. What's up?
So asking us to do it by elimination. Are we still doing it by elimination? Because it seems like we're also substituting as well.
Well,
right now.
elimination just gets rid of one of the letters. But even when we were solving linear equations through elimination, once you know one of the letters, you have to substitute it in to get the other one. So there's always going to be substitution somewhere. Let's subtract a 4 from both sides. Gets me 2x equals negative 6. Dividing by 2 shows me that x equals negative 3 when y is 4. So one of our solutions is negative 3 comma 4. Remember, x always gets written first. Over here, add 2 to both sides. And what you get is 2x equals 0. If you divide both sides by 2, you get x equals 0. So the other place where our straight line and our sideways parabola cross each other are, or is, the other place is 0 comma negative 2. Does it always have to be a straight line and a sideways parabola? No, that's just how I chose to do the questions. These are our solutions. On the test, am I going to know if you use substitution or elimination? No, because it really doesn't matter. It's whatever method you prefer or whatever method makes the question easier. Heck, if you decide to solve by graphing, more power to you. I just want to make sure that you can solve a system of equations. This one or the next one? Let's see what the next one is. Solve the quadratic equation by graphing. Oh, we're going to solve by graphing. The way we're going to do that is we are going to graph the first one, negative x plus 3. That's the left side. I chose to write it as negative x plus 3 so you can see that it is just y equals mx plus b. And the right side will be the second equation, x squared minus 2x minus 3. Let's graph our straight line. This is what we did in that lesson, where we graphed the straight line and we graphed the quadratic and we looked for where they crossed each other. This is what I was trying to get you to do on the back of homework number 5. So I was trying to get you so that when we got here, you already knew how to do it. This is a y-intercept of 3 and a slope of negative 1. So that's down 1, right 1, down 1, right 1, so on and so forth. Grab something straight and connect your dots. There. Now we have to graph our quadratic, and unfortunately for us, it's in the hardest version to graph. It's in standard form. Ugh. Well, we got to do what we got to do. First thing we know, its y-intercept is at negative 3. That's free information. Oh, that's really all we know other than the fact that it points up. We need to track down the axis of symmetry. X equals negative b over 2a because it's standard form. So negative, your b value, use parentheses please when you substitute. And lucky for us, a is 1. That gives me 2 over 2. So x equals 1 is my axis of symmetry. I can now reflect over the axis of symmetry and get to here. In order to get the y value of that vertex, which we know is going to be down here somewhere because the quadratic points up, you're going to have to substitute in x equals 1 up here. So we get that y equals 1 squared minus 2 times 1 minus 3. 1 minus 2 minus 3 is, what is that? Negative 4. That doesn't make any sense. What did I do wrong? Right, but this quadratic points up.
Yeah, it points. Oh.
Wait, what happened? What'd I do? Oh, that's -5, not -3? Goodness. Okay. Oops. All right, you guys go away. Those were mistakes. That number's -3, which is way up here. It's typical I don't record first period, but as you can hear, my voice is a little bit fried, so I didn't want it to get worse for the video quality. Okay, that's better. 1 minus 5 is -4. That makes a lot more sense. Now we have an upwards facing quadratic. Oh, you know what kind of stinks, though? We're going to have to estimate unless we have more points of this quadratic. All right, what's up?
So, what does y1 mean?
That y1, y2 just means first equation I'm graphing, second equation I'm graphing.
So, did you simplify the top equation or did you add 3?
No, I did that. But 3 minus x doesn't look like slope-intercept form, so I just wrote it as -x plus 3.
And y2 is the other side of the equation.
And then y2 is the other side. Yep.
And then you did
And then I graphed the straight line
-b over 2a.
for this one.
Yeah.
Mm-hmm. Which is that purple line.
Okay.
Okay. So now what? Well, you need more points, don't you? So plug in the next x value. How about x equals 1? No, not x equals 1. One more to the right would be x equals 3. How about x equals 3? Let's see. Well, 3 squared minus 2 times 3 minus 3. That is 9 minus 6 minus 3. That's 0. Oh, 0. Oh, you know what we should have done?
What?
We also should have seen that this factors.
Oh.
You gonna make it? Okay, we could see one of our intersections is right there. We can see one of our intersections is right there. The other intersection is clearly over here somewhere, right? So I need to figure out where that's going to be. See, this is why graphing for solutions is not always the best option. We're still kind of guessing and checking our way there. Let's hope it happens at x equals -2.
I don't think it will. Actually, I think it will.
Let's find out. I actually have no idea.
I think it will.
4 plus 4 minus 3. That is 8 minus 3, that's 5. -2, comma 5, bingo, we found it. Nice. So our solutions are where these two graphs cross each other as coordinates. At -2, comma 5, and at 3, comma 0. Did you notice that that one took more work than the other two? Solving by graphing is my least favorite method. What I would have done was I would have added x and I would have subtracted 3 and I would have solved by factoring. If you add x and subtract 3, you get x squared plus x minus 6. Are there two numbers that multiply to -6 and add to 1?
3 and 2.
Oh yeah, see how much easier this is? Look how fast that is. So solving by factoring, that should be your go-to. Solving by graphing, it literally should be your last option. Look how much faster we could have gotten there. Either way. So why is it here? Because, like I've said in the past, one of the things that you're supposed to understand from all the way back in your Algebra 1 days is when you solve for anything, what you're actually finding is the places where the graphs would have intersected. That's what that means. This solve for x thing. People say, oh, are we going to solve? What does solve mean? Solve means, in reality, if you graph it, where do the graphs cross? Everybody's favorite, word problems. Luckily, we all speak this English language that we, know and love. Colton wants to increase the size of his rectangular patio by increasing the length and the width by the same amount. That means if he makes the width go up by 1, he's got to make the length go up by 1. The current patio is 6 feet wide and 8 feet long. If he wants the area to be 80 square feet, because right now it's only 48, 6 times 8 is 48. If he wants the area to be 80 square feet, by what amount should he increase the length and the width? I can tell you that I never attempt to solve a question like this without a very specific aid. What do you think it is? A drawing, yeah. So I'm gonna draw something first.
Patio.
Yeah, I'm gonna draw a patio. Now I'm no artist here. I'm a mathematician. So I'm just gonna draw a rectangle. We know that right now this patio is 8 feet wide. Nope, 6 feet wide and 8 feet long. There we go. Doesn't really matter which one you put where. Now let's pretend for a minute that the answer's not going to be pretty and you can easily guess it. Because, at least one person's already held up their fingers to show me the answer. But that's because the question was designed to be easy for the notes. Let's assume that it requires work. Let's assume the answer might not be pretty. Will, what would you like to try to do? Without guessing and checking, how would you set this up?
Well, how would I set it up?
Yep.
Well, I already know the answer.
Well, the answer is unimportant to me. How we get to the answer is what I care about.
I only know actually, because what I did is I just plugged in numbers.
You plugged in numbers, but what if the answer was 2.35? Would you have ever think to plug that in?
No.
Nope. So let's assume for the sake of education that on the test the answer will not be a whole number. Okay? So what we need to do is have an algebraic way of solving this. Harrison, you have an idea for me?
I mean, I drew 2 rectangles and then I made I don't know how to explain what I did, but I made 6 over 48 is x over 80, and then I just
6 over 48 is x over 80?
Yeah, I'm solving because I have one side and then I have the area, and then I have one side and I have the area.
But you don't have one side.
And then I don't have one side and I have the area. So I did the side over the area and then the side over the area.
So you recognize that yeah, that won't always work.
No?
You set them up as similar figures, but similar figures are found through multiplication, not through addition. So it just so happens, I don't know if you got the same answer.
What's the answer?
The answer is 2. Okay, so it didn't work.
I did it for 6, but I got
Right, but it doesn't matter. The answer is they have to both go up by 2.
Oh, true.
So what you tried to do is set them up as similar figures, but similar figures can't be found through addition. So we have to do this algebraically. Okay, Sebastian?
Because we're adding the same amount to both sides, we know that one's going to be x, one's going to be x plus 2. Because 8 is 6 plus 2.
Okay, so you're not wrong about that. That works as well. But what I want to focus on is the fact that you said since we're adding the same amount to both. And since we're trying to figure out how much we're adding and we don't know what that is, what would you call it? The amount, since we don't know it? X. Yes, it's a variable. So let's do this. We know that we're going to add an unknown amount to both sides, and we know that when we are finished, our area will be 80. There it is. An area is found by multiplying length times width. So we go x plus 6 times x plus 8 equals 80. Foil here. Since this is an honors class, I'm going to assume that you all know how to foil. And because we're dealing with a quadratic, you're going to have to bring it all to one side to solve. What is that, 32? 32. So what we are on the hunt for is two numbers that will multiply to negative 32, but add to 14. It's 16 and 2. One of them has to be negative, but we need them to add to be a positive. That makes the larger of the two numbers the positive number. So that gives us x plus 16 times x minus 2. That gives us two options for solutions. We have x equals negative 16, and we have x equals 2. And since we're talking about a real world question where we're increasing the length of something, and since there's no such thing as negative lengths in the real world, this would be an extraneous solution, and our only answer is we increase both by 2. What this is going to show you, though, is that there might have been two answers, because it's not always guaranteed that one of them will be extraneous. It's extraneous because 8 minus 16 is negative and 6 minus 16 is negative, and you can't have negative lengths. But we need to always be solving them algebraically just in case the answer's ugly, or just in case there's two answers. Harrison, what's up?
If there's two answers, that just means that there's like two ways to get to it.
Right.
There can be two answers.
If there's two, there could be two answers, yes. Which means, yeah, there's two different ways to make it happen. Because here's the thing. It could have been that, well, I'll keep that one to myself. Just assume that you won't be able to guess and check your way to the answer on the test. And on the homework, since I give you the answers, you have to actually do it this way to get credit for that word problem on the homework. One last question. Eek! 2 quadratics.
Oh no.
I know, right? Dag nabbit.
Oh god.
2 quadratics, looking for the place where two U-shaped graphs cross each other. And it doesn't matter if you choose to use elimination or if you choose to use substitution. It's completely up to you. But please, work smarter, not harder. What do I mean by that? Well, you might be looking at it right now going, true, I could just use elimination because if I add straight down, x squared is gone. Well, I mean, you're kind of right. But if you add straight down, you still have x's and y's. You'd still have two variables. And since you'd still have two variables, you would still need two equations to solve. Which means elimination is not your friend here. Because elimination, at least for these x squareds, it's not going to make one of the variables disappear. The whole idea behind elimination is to make one letter disappear. So could we still use elimination? We could. If you wanted to make the y's go away, you could do that. But here's the thing. Again, we're trying to work smarter, not harder. You're trying to be lazy. You're trying to do as little work as possible, right? Notice this top equation already isolated y. I've already told you what y equals. So why not just take what y equals and substitute right there? And every time you substitute, use parentheses. Been setting that skill up all year, haven't I? Hey, look, only one variable, x's. I mean, yeah, and x squareds, but whatever. Distribute the 3, bring it all to one side, and solve like we've done for every other question. Negative 3x squared plus 15x plus 18 equals x squared minus x minus 2. Since we're hoping that we can solve by factoring, we want the leading term to be positive. So I'm going to bring everything to the right. I'll add 3x squared. Oof. There's going to be a 4 in front of my x squared. We might have to do the Lizzie method again.
No.
Well, we'll see.
No.
Subtract 15x from both sides. Subtract 18 from both sides. Now you have a 0 on the left. On the right, we have 4x squared. Negative 1 minus 15 is negative 16. And negative 2 minus 18 is negative 20. Yay! There's a GCF of 4. So because we're solving for x, we could actually get away with just dividing both sides by 4. But because I don't want you to have to try to remember when you're allowed to do that and when you're not allowed to do that, because again, memorizing instead of understanding, not really a good plan for Algebra 2. What I'm going to do instead is just factor it out and leave it as a GCF. Undistributing the 4 is going to get me x squared minus 4x minus 5, because factoring is a form of division. And yay. There are two numbers that multiply to negative 5 that add to negative 4. Negative 5 and positive 1. Hooray! We could see our two solutions for x. We could see that x equals negative 1 and x equals 5. Just like we've done in the other questions, it's time to do some substitution. Take what you know x to equal and plug it into either equation. It doesn't matter which one you choose, but I'm going to go with that one that I circled in blue because I'm trying to solve for y, and y is already alone there. So negative x squared plus 5x plus 6. Every time you substitute, do it with parentheses. And I'm dropping in my x values that I just found. Exponents first, please. So negative 1 minus 5 minus 6 looks like negative 12 to me. So when x is negative 1, y is negative 12. There's one of our solutions. Exponents first, please. Exponents first. PEMDAS. The negative 25 and the positive 25 cancel, leaving us y equals 6. So our other solution is at the coordinate 5, 6. And we have the two places where those U-shaped graphs cross each other.
Mr. McCutcheon.
Hold on. Okay, he's asking a question and he's asking a question. His face says I made a mistake. Yes?
That negative 6, it should be positive.
Negative 6 should be positive here.
Yeah.
Wow, I wish we would have caught that sooner. But yes. Poop. So that's 0, isn't it?
Yeah.
Yeah. This is why I don't record first period.
How did I get 10?
I'm not sure how you got 10.
Oh, because that's negative 2.
Where'd you get negative 2?
I plugged into the... Oh, I multiplied by 3.
Oh, you forgot the triplet?
Yeah.
That'll do it. Well, anyway, now that we've found my goof ups,
Wait, your extra what?
I think we're done with this one.